faculty meeting last week. One of our own, Amari, was recognized for a program you participated in. What was that? Third Good Marshall, yeah. One of only about 3 or 4 from the college? Yeah, okay. Way to go. All right. We'll go from current slide. I guess we'll go from current slide. All right. We finished example 2. I don't know why we're still on this slide. My memory is sketching the graph of a rational function, which is what we've been doing. Before we get started, any questions on anything we've covered so far? Now, let's just look ahead into the crystal ball a little bit. If we do finish the section today, which we have a very good chance of doing, I'd say an excellent chance of doing, we're not doing 2.7, so that means we should be ready for the test on Tuesday. Okay? Okay, such comics. Okay. But you do get your formula and equation sheet, so it's almost as good. Okay? That means I need your quizzes in. Now, if you can't get them to me today, I'll be on Birmingham campus tomorrow from 8 to 12, so that should be a possibility. Or Monday. If you can get them to me Monday, I'm on this campus from 8 in the morning until 6 in the evening. Now, I'm in class part of that time, but if I'm in class and you can't get it to me in person, you can slide it under my office door, which is room 265. Here we are here in this classroom. Go down the long hallway here, take a right, go down a half flight of stairs there. Before you get to hit the end of the wall, in between the stairwell and that mechanical room, that's my office right there, 265. So if you can't get it to me while I'm in the office on Monday, get it to me sometime. Slide it under my door, and I'll get it. Or you can turn it in Tuesday morning. I just can't have it graded for you before the test. I'd like to have it graded before the test so you can see if you made any errors, and if you did, get those corrected. I hate for you to make the same mistakes twice. But if you don't get it into me until the day of the test, you have no way of knowing if you made a mistake. Yes?
Can I see mine before I leave?
I'm sorry?
Can I see mine quiz before I leave?
Sure. Yeah. Come see me after class, and I'll let you see your quiz because they've all been graded, all that have been turned in so far. Okay. Any questions then? Yes? I'm sorry? Before the end of the term. Okay? If you get it into me this week or next week, I think that brings us to the end of November, doesn't it? Is there one more day in November the following week? What is Monday of the week after Thanksgiving? Say again?
That Monday would be
December 1st, okay? So if you get the paper to me this week or next week, you still get that one remaining bonus point, okay? Once Thanksgiving's over with, we're in December, no more bonus points on the table, okay? And here's Kenny. All right. Good question, yes? A little louder.
last week of Thanksgiving is the whole campus.
Okay. No, good question. Going to talk about it next week, but I'll talk about it now. The week of Thanksgiving, you have the whole week off. Okay? We don't. We're here Monday, Tuesday, and Wednesday. Okay? We have holidays Thursday and Friday. And campus is closed Thursday and Friday. But because we're here, the campus is open Monday, Tuesday, and Wednesday. Now, let me say this. They usually run what they call professional development Monday and Tuesday, and most of the time that's on the Birmingham West campus. So I won't be on this campus more than likely Monday or Tuesday. In fact, I know Monday and Tuesday of Thanksgiving week, both days I have appointments at I Foundation Hospital, but it won't be all day. but it'll be, I think, first thing or early in the morning, and then as soon as I'm through, I'm going to the Birmingham campus. So I'll be over there, but we'll be in meetings most of those 2 days. Then on Wednesday, we're back in our offices. So I'll be back on this campus Wednesday morning, but don't bank on taking care of too much business very long on Wednesday, because it's very likely, not required, but very likely they'll let people go home early on Wednesday. They do that typically, sometimes shortly after lunch, sometimes 1 or 2 o'clock, something like that. They don't have to do it, and they're not guaranteed they'll do it, but I wouldn't bank on getting that last payment done Wednesday afternoon at 5. Don't bank on that one. There won't be many people around to take care of. So if you're going to take care of business on Wednesday, try to do it early, okay, Wednesday morning. Once they let us go, there's not too many people that hang around, okay? All right, good question so far. Any others? How about any math questions? Oh, you know all that. Good. Okay. All right. So we've been doing some of this, and we're going to continue. Sketching the graph of a rational function. To sketch the graph of a rational function, use the following guidelines. Okay? For those who haven't been here, sorry about the cold. It's getting better, but today it's more of a dry cough, which I really hate, but it's getting better. So, what is a rational function? It's a function that has a polynomial numerator and a polynomial denominator. Ratio of 2 polynomial functions. N of x and d of x are polynomials. D of x cannot be the 0 polynomial. You can never divide by 0. So, first step before you even start graphing the function, simplify if possible. That means factor the numerator, factor the denominator. See if there's any common factors. If there are, simplify. Get them out of there. Remember them, don't forget them, because if there's, say, an x minus 3 in the denominator and in the numerator, and you get rid of them, the function still cannot equal 3. Because that original function, that would make that denominator 0. Okay, so remember, don't forget them, but simplify. Factor them out, but remember where they were. Okay? Now, once you've done that, now, the order of this doesn't matter. The idea of factoring numerator and denominator, that's a great idea. Now remember, if these are big old polynomials, you're going to have to use every technique we did back in 2.5. Rational zeros test, Descartes' rule of signs, upper and lower bound test, all these things. Use every tool in your belt to figure out what the factorization of the numerator and denominator are. Okay? Do that first. Simplify, certainly. But remember, any that you eliminate that you still can't use, x equals 3 or whatever it is. Now, they say, and this is a good idea, that one of the easiest things to do, and actually it's easier before you factor. Before you factor, and in fact, I would move this up here. If you got a polynomial here and a polynomial there, it's real easy to put 0 in for x. Right? You put a 0 in for x, all you have is the constant terms. So the ratio of the constant term, that's going to be your y-intercept. Now, will all functions have y-intercepts? Not necessarily. The y-axis is a vertical asymptote. There aren't going to be any y-intercepts. So that's why they say, if any. How many y-intercepts might you have? Any ideas? Let me give you a hint. Vertical line test. 1! You can't have more than 1. Okay? So, find it if there is one. If there's not, that probably means the vertical axis, the y-axis, is a vertical asymptote. Okay, so that I would move up here because it's easiest to evaluate f of 0 before you factor. Then factor and simplify. Okay, find the zeros in the numerator. Now this can do any order you want to, But since you've already got it factored, everything in the numerator, with that numerator 0, that will make the function 0. Okay? Those x values that would make that numerator, like if you had an x minus 3 or x plus 7, then positive 3 or a negative 7 would be zeros. Plot them on the horizontal axis. Okay? It's real easy to do. You've already factored it. You did that in this step. So just find those zeros and then put them on the x-axis. Okay? Then find the zeros in the denominator. You already got it factored. Look for the zeros there. Every time you find the zero in the denominator, vertical asymptote, vertical asymptote, vertical asymptote. It has to be, because the denominator can't be 0. So anytime you find the 0 in the denominator, that's going to be a vertical asymptote. The function cannot touch or cross that number. Okay? So, what you've done so far is found the y-intercept, the x-intercept. How many x-intercepts can you have? Up to n, whatever your maximum degree of your numerator. You may not have n, but you can have up to n zeros in the numerator, and that would be how many x-intercepts you have. All right, so we've done that. Now, and you've already done, if you did this, find the zeros in the denominator by setting each factor equal to 0, then put those vertical asymptotes in. Then find and sketch the horizontal asymptotes, if any. Now you can only have one, or you may have none. How do you find the horizontal asymptote? Remember that one? Horizontal asymptote is where the function's going in the long run. Infinitely negative, infinitely positive. Or when Karen gets here. Okay. There she is. All right. How do you find? The reason I said in behavior for a rational function. How do we do in behavior for a polynomial function? Look at the leading term. So what do you think you do with a rational function? It's the ratio of two polynomials. The ratio of the leading terms. See what that is. So let's think about that ratio of leading terms. What if the degree of the numerator is greater than the degree of the denominator? You're not going to have the horizontal asymptote, because that's still acting like a polynomial function. Okay? Because you have an x there, okay, in the numerator. What if the degree of the denominator is greater than the degree of the numerator? What's your horizontal asymptote? What happens at x is it's very, very big, but it's in the denominator. 1 over x. It goes to 0. Okay, so y equals 0 will be your horizontal asymptote. But if the degrees are the same, maximum exponents are the same, those leading terms have the same n, have the same exponent, then just look at the ratio of the coefficients. That will be your horizontal asymptote. Okay, so look at the ratio of the leading terms. That's your horizontal asymptote. Okay? Now, here's where the book and I sort of differ a little bit. Okay, let's mentally image what you've got now. You've got your axis here, and you put your y-intercept there. That was easy. Okay? And then you did all your x-intercepts. That was where the numerator was equal to 0. You put all those x-intercepts in there. Then, where the denominator was 0, or couldn't be 0, those are your vertical asymptotes. So what do you have on the x-axis? You have all your zeros somewhere there, and you have vertical asymptotes there. Okay? Now, what that does is split up your domain into a region outside the very leftmost one of those, in between the next two, in between the next. So you have a bunch of regions there. Okay? And they say plot at least 1 point between and 1 point beyond each intercept and vertical asymptote. Do you need to do that? Always? Not necessarily. If you can get by without it, get by without it. But if you don't know what's going on in that interval, then do a test point. Okay? Now, we'll show when that comes up. Use smooth curves. Don't ever do angles. Smooth curves to complete whatever is going on in between and beyond those zeros and vertical asymptotes. All right. A lot of blah, 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 right? Let's see how we do it. The concept of test intervals can be extended to graphing rational functions. That's what we were just talking about. Those intervals where you don't know what's going on between a zero and a vertical asymptote, or between two zeros, or between two vertical asymptotes. You don't know what's going on, use it. That creates a test interval on your x-axis. To do this, use the fact that the rational function can change its signs only at its zeros. It doesn't have to change signs at zeros, but that's the only place it could. Because you see, if it's got a zero here, it's either going to stay on the same side, cross, or stay on the same side. Those are only three options, okay? So, you might need a test point on either side of that zero to see which way the function's going, okay? So at its zeros or its undefined values, which are the vertical asymptotes. Between two consecutive zeros on the numerator and the denominator, that's your numerator are your zeros, your denominator are your vertical asymptotes, the rational function must be entirely positive or entirely negative. And again, a lot of blah, blah, blah. Let's see if we can work one. Oh, still more blah, blah, blah. This means that when we put in order the zeros of the numerator and the denominator, zeros of the numerator are your x-intercept, zeros of the denominator, your vertical asymptotes of a rational function, that they divide the real number line into test intervals, in which the function has no sign changes. So if you find out where it's there, it doesn't cross. If it crosses, it'd be another zero, okay? So, you know it has to stay above or below anywhere of these test intervals. Okay. So what you do is choose a representative x value somewhere in that interval to determine whether the value of the rational function is positive or negative. Positive is going to be above the x-axis, negative below. You need that. Okay. Here's example 3, finally. Oh boy, did they ever pick a hard one for us. Okay. Let's go through. Well, you tell me what you want to do first. Let me get my pen set up. If we're going to sketch the graph, what would be one of your first steps? Second? Domain? Okay, what would be your domain? Not a bad idea. What's the domain of that function? All real numbers except 2. So anything to the left of 2 is a fair game. Anything to the right of 2 is fair game. What can you say about x equal 2? It's a 0 in the denominator, which makes a what on your graph? A what? What on your graph? What you plot on your graph? Vertical asymptote, exactly. Okay, so here we go. We can start this already, and we just got here. Okay, so let's tick off a few points. Oh, I forgot to make any announcements today, didn't I? Okay, the only major one I know about, I know there must be some out there that I haven't seen or printed off or something, but here's the one. The SACS team has been here this week. Okay, what SACS is a Southern Association of Colleges and Schools. They are our accrediting agency. And every decade, you have to get reaccredited. Okay? Now, we've been working at this for well more than a year. Okay? All these signs you see about race to the finish. That's our QEP. That's part of SACS. That's why you've been seeing the brand new, nice looking signs. Okay? That's why you've seen a little bit of painting going on, the smell of painting going on. Okay? That's why that's why there's not as much stuff in the hallways. The floors were all waxed. Okay? That was because we were getting ready for SACS team. Okay? They've been here Tuesday, Wednesday, and today. Supposedly today, right now, they're over on the Birmingham West Campus in the ACAT building, probably in the auditorium there, reporting on what they found. Now, again, we have already done all the paperwork that had all been taken care of months ago. Okay? They've fed it, given us feedback on that. We've made corrections on that months ago, maybe weeks ago. And then they came to see how we actually did things. Were we doing what we said we were going to? Was our QEP what we said it was going to be? All this kind of stuff. And they're giving the report probably right about now. So, they should be over with sometime maybe this morning. Except the crying. No, hopefully there won't be much crying. There may be a few recommendations. They'll probably be taken care of in the next few weeks. Everything will be copacetic. Okay. So that was the only announcement I knew about. Let's move on. So you just told me x equal 2 is a vertical asymptote. And I kind of like to draw vertical asymptotes red. So I put my vertical asymptote right there. Okay. So what didn't have to be the first and the only thing you did. I mean, the first thing you did, but it's one good choice. Okay? And by the way, that establishes the domain, all real numbers this way, all real numbers this way, but not at x equal 2. All right? What's another thing you can do? Say again, horizontal asymptote. And what would that be? Let me go back to, well, let me leave it like that. Ratio of the leading terms. Now, what's the ratio of 3 over x when x goes very, very large, positive or negative? 0. Because 3 over 1,000 would be 3 thousandths. You know, that's small. 3 over negative 1,000, that's small. Okay, really small. And they keep going. So your horizontal, your x-axis is your horizontal asymptote. Okay. Now, does that mean that you can't have a 0, a horizontal x-intercept? Not necessarily. You see, the function can touch or cross a horizontal asymptote. It can never touch or cross a vertical asymptote. So, you could have a 0 there. Do you think we do? Any ideas? Think we have a x equals 0. Someplace where y is equal to 0. That's going to be no, because your numerator here is 3. And in order, what's your y, by the way? Say again? I can't hear you. What's the y? This goes way back. What's y always? Except it's not f, it's g of x. Okay, so your y is g of x. If this is 0, that means your numerator has to be 0. Can 3 ever be 0? Not in this universe. Okay, so there is no x-intercept. None. Okay, what else might we do? We've done the vertical asymptote, the horizontal asymptote. We found out there are no x-intercepts. What's one more thing we might find? Y-intercept. And where is y-intercept always? Hence, hint, the x-intercept was where y was equal to 0. There aren't any. So where are the the y-intercepts? Where x is equal to 0. What happens if x equals 0? Negative 3 halves. So your y-intercept is at negative 3 halves. I'm going to go back to black now. Okay? Negative 1 1/2. Okay? Guess what, team? We don't need a test point over here because your y-intercept does that for us. Okay? We know that the function, as you get more and more negative, has to be approaching your horizontal asymptote. As it gets more and more positive here, it's got to approach your vertical asymptote. Why? If it tried to go up this way, you'd have a zero. And we've already said you can't have any zeros there. No x-intercept. So it has to be going down. So in this case, see, if I can avoid those test points, I'll avoid them. Okay. But I can't avoid the one other. We have no other clues to the right of x equal 2. So we have to pick a test point. Pick a point. Any point. I may not like it, but pick one. Say again? -3? Okay. That's over here, and I already know where the function is there. Somewhere down there. +3 would be a great one. Okay? So let's pick x equal +3. G of 3, wow, that rhymes, is equal to 3 over 3 minus 2. What's that equal to? Second? I can't hear.
3.
Not quite. 3 over 1, which is? Okay, 3. You got it. Okay. 1, 2, 3. There it is. 3 will be 3. There we have it. We know where the function is here, don't we? As it goes closer to the y-intercept, it's going to infinity. As it goes closer to the y-asymptote, it's going to infinity. As it goes closer to the x-asymptote, as x gets larger and larger and larger. I mean, the horizontal asymptote. There we have it. That's not too bad, is it? Okay? Let's review what we did. I should have been writing them down. Okay? First thing you found was your vertical asymptote. You didn't have to do it in this order, but that's what you did. And that was at x equal 2. Wherever the denominator is 0, vertical asymptote. So we got that. Then you decided to do the horizontal asymptote, and that was the ratio of the leading terms, and that gave us y equals 0. And that's what I drew in there. I probably should have done those in red. Okay? Then we did the y-intercept. Okay? That's where x is equal to 0. That was easy to do. That was 0, -3/2. Okay? And then we did the x-intercept. Okay? X-intercept, there were none. That were y is equal to 0. 3 is never 0, so it could not be. None. Okay? Then the next thing was do test points. And this time we only needed one. Okay? Because we already knew where it was going over here because of the y-intercept. We needed to find out where it's going here. We found out that was going to be up there. So, we got our graph. That was a really easy one because I only had a monomial in the numerator and a binomial in the denominator. So that wasn't too bad. A linear binomial in the denominator. So that was pretty easy. Any questions? Let's see how they did it. All right for me to erase? Yay? All right. Okay? They started with the y-intercept. It doesn't matter where you started. Okay? But the y-intercept is real easy to do. Plug in x equals 0. You get x equals 0, y is equal to -3/2. Now notice something, folks. Intercepts, y-intercepts, x-intercepts are always points. Points are always ordered pairs. So write them as ordered pairs. It's pretty nice to do. So y-intercept was pretty easy. Okay, what did they choose to do next? X-intercept. That's where y is equal to 0. There are none, because if you set y, which is in this case g of x, equal to 0, there's no way that 3 over anything is going to be 0. Ever. Okay? So therefore there is no 3 is not equal to 0. Good choice. Then they did vertical asymptote. That's anything that makes the denominator 0. That would be x equal 2. I like to say x not equal to, reminding myself I can't put a value there because that makes it 0 in a denominator. And that's the only one we have. Then they did horizontal asymptote, and that would be the ratio of the leading terms, 3 over x, is x is very large, is going very close to 0. Make sense? They say because the degree of the numerator is less than the degree of the denominator. You just look at the ratio of leading terms and let x get very big. That's going to 0. You got it. All right. And then they graph. Oh, now they do additional points. Okay? You can choose -4 if you want to. Why would you? Okay? You already chose a point. X equal 0. And that gave you your y-intercept. You already got a point there. Okay? But we did need to choose one. They chose x equal 3. We chose x equal 3 after some coercion. And that gave us 3, 3. And that was positive, so you know you're above the x-axis here, and you're below there. See, that point was extraneous. I mean, it's fine, yeah. It may help you see what the shape was, but, you know, we knew what the shape was going to be. It's going to be approaching the horizontal asymptote there, approaching vertical asymptote here. Once you get this point, approaching vertical asymptote there, horizontal asymptote there. Done. Done. You don't have to have it perfect, you know, the curve just right. Be happy with it, okay? Any questions? Everybody see it? Okay. Domain, now they say the domain. You started with that. All real numbers except x equal 2. Why they put that in now, I don't know, but it's true, absolutely. What's the range? They didn't say that, but what's the range? Say again? All real numbers except y equals 0. Okay? That's the range. All right. They're skipping example 4, 5, and 6. Okay? So let's go back and do 4, 5, and 6. Sketch the graph of f of x is equal to 2x minus 1 over x. And state its domain. I forgot they said state its domain. Because Rachel took care of that very first thing. All right. So what do you want to do first? Up to you completely. If you're wrong, I'll tell you. Okay. What you want to do first? Doesn't matter. Anything will work. Second, domain. What's your domain? Second, all real numbers except what? Except x equals 0. Okay. You want to put it in interval notation, set notation? How do you like to write it? I don't care too much. How do you like to write your domain? Okay, you want to do that. We'll word it in words. All reals, I'm just going to do that. That stands for reals, except x cannot equal 0. Now, that also tells you something, doesn't it? It tells you two more things, if you think about it. What's one thing it tells you? Yeah, say again. That's a vertical asymptote. X equals 0 is a vertical asymptote. Okay? One more thing. Remember the 4 things we do right off the top. This takes care of another one. Say again. Okay, it doesn't say much about x-intercept, I don't think. But it does say something about the y-intercept, because you set x equals 0, you can't have it. So this tells you 2 things right off the bat, or whatever, that the vertical asymptote is x, I like to say, cannot equal 0, and the y-intercept None. You don't have to put parentheses around it. Okay? Absolutely none, because you can't set x equals 0. That's how you get your y-intercept, is setting x equals 0. Can't do it. Okay. So we got our domain, which they asked for last, but we already got it. We got a vertical asymptote already, and the y-intercept already. Whoa, get out of there. Okay. Now, what's left? Say again? I can't hear. Horizontal asymptote. We'll do that next. The HA. Okay. What is true about the horizontal asymptote? How do we determine it? Ratio of the leading terms. And what's the ratio of 2x over x? 2. There's your horizontal asymptote, is y is equal to 2. Because you see, f of x is what? Y. Okay. So y is equal to 2. Okay? And one thing we still haven't determined, x-intercept. And what would that be? Where what? X. The x-intercept. 1 over 2, is that what you said? Yeah, okay. I'm sorry. Okay. Yeah. That would be, x-intercept would be x equal 1/2, y equal 0. Because how do you get the x-intercept? Set y equals 0. The only way for that to be 0, the numerator is 0. 2x minus 1 is 0. Add 1 to both sides. Divide by 2. X equal 1/2. All right. Let's graph what we can, and we'll try to figure out the rest. Okay. Now, I'm going to change back to my red here. Okay. Oh, let me put my points in first. Okay. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4. Okay. Now, let's do vertical asymptote in red, because I like to do it in red. What is that? That's the y-axis, where x equals 0. Okay? So x can't be 0. What's your horizontal asymptote? Y is equal to 2. So draw that where y is equal to 2. Get out of there. Okay? Now, no y-intercept. We can't plot anything there. You can't touch that line because that's the vertical asymptote. But the x-intercept we can do, and that's at 1/2, 0. Right. Whoa! This should be dark again. Okay. All right. Now, that takes care of one thing for us, doesn't it? We don't need a test point this way. We already got one. Right? So the function has to be going toward the x-intercept that way, toward the y-intercept that way. Done. Okay? But what do we need? Test point where? Second? -2. Okay, she likes big numbers. Okay, so the f of -2, and that will be 2 times, get out of there, okay, -2 minus 1 over -2. Well, what's -2 minus 2 times -2? -4 minus 1 over -2, that would be, help me somebody. Say again? 5 over 2, which is 5/2, which is 2.5, right? 1, 2.5. So out here, x equal -2. You're at right there. I think we have a good idea where it's going. As it gets closer to the vertical asymptote, it has to be going to infinity. Close to the horizontal asymptote, it has to be going closer to 2. There we have it. Don't need but one test point here. Let's see how the book did. Oh, look at that. They even used 2 test points over here, 1 between here, y, unnecessary, and 1 over here, y, unnecessary. But it's perfectly fine to use them. Because once you have a point here in this quadrant, you know where it has to go. And once you have this, I would have chosen -1 because the numbers are small. I'm really lazy. That would have put us somewhere up here, and we would go there. All right, good deal. Any questions on that? Ask me. Is it making sense? Earth to class, come in, please. Okay, yes, okay, good. All right, so that was example 4. And and by the way, every one of these examples has, guess what? A checkpoint. So please do your checkpoints as soon as you can after class, because you can always go to larsonprecalculus.com and see an audio-video solution to those checkpoints. All right, so can I clear my slide now? Because this one I don't have a backup on the slide set. Everybody got it? Okay. So let's erase all that and do example 5. Sketch the graph of this one. F of x is equal to x over x squared minus x minus 2. Now, what might you want to do first? Okay, factoring is a good idea, but remember I said there's one thing that's easier to do before you factor. Set x equals 0. Remember, that gives you your y-intercept. So do it now before you factor it and mess it up, okay? So what happens when x equals 0? F of 0 is equal to 0, which means your x-intercept and your y-intercept is, or at least one x-intercept, no, your y-intercept is 0 and you only have one, so your y-intercept is 0 and one of your x-intercepts, is that right? Yeah, I guess so. Okay, so 0, 0 is both an x-intercept and a y-intercept. Okay, there may be more x-intercept. No, take that back. You're okay. Okay, now let's factor. So this is going to be x over, how does that denominator factor? The numerator I factored. Sorry, I already did it. Okay, pretty easy. How do you do the denominator? X minus 2 times x plus 1. Now what does that tell you? Okay, what zeros? And say again? You're probably saying things right, I just can't hear. Vertical asymptotes, and what would they be? X what? Okay, x cannot equal minus 1, and x cannot equal, what'd you say? Positive 2. Okay? Okay, we got x-intercept, y-intercept. There aren't any other x-intercepts because the x-intercept is for y is equal to 0. Only times y is 0 is when that numerator is 0 and that 0. So we only got one x-intercept, only got one y-intercept. You never can have more than one y-intercept. We've got our 2 vertical asymptotes. Okay, what are we missing? Horizontal asymptote. How do we get the horizontal asymptote? Ratio of leading terms. And what's the ratio of x over x squared? 1 over x, right? What happens to 1 over x when x is very large, either positive or negative? To 0, going to 0. So your horizontal asymptote is what variable? But what variable? No, not x. Y, yeah, good choice. Okay, y is equal to 0. Okay, because if you think about it, your ratio here is your y value for very large x's. Okay. All right, so let's Now proceed to graph. All right, let's tick off some points. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6. Negative 1. Get out of there. And 1, 2, 3, 4, 5, 6, 7. Okay. Now, which you want to plot first? The which? X-intercept. And what is it? Which is also your y-intercept. Only got one x-intercept, one y, and always no more than one y-intercept. So there, we plotted that. Next, vertical asymptote, where? Okay, x not equal to -1, that goes up this way, and not equal to +2, that goes up this way. All right. What's that?
How come in the book they write that it is equal?
Okay, that's the way they do it. I just do it to say it's not equal because I get it from here. The denominator cannot equal 0. So x minus 2 cannot equal 0. X plus 1 cannot equal. That's why I do it that way.
But it is a vertical asymptote.
It is a vertical asymptote. They say that's where you can't go. I say you can't go there because it's not equal there. So it's the same thing. Okay? Yeah, if you like it the way the book does it.
Well, that's what I was getting at. If we wrote it either way.
Yeah. I give you credit for it. As long as you get it right, I give you credit for it. One other thing we haven't plotted yet. And how do I plot the y horizontal asymptote? That is the x-axis. Now notice here, this is an example. You see, there can be a point on the horizontal asymptote. There never can be on a vertical asymptote. This point is right there on it. But this is one of those examples we got a bunch of test points to check because we don't have a clue what's going on in this region. Okay, let me pick another color, not black or red. Say again, green? Okay. What did you say? Blue, okay. All right, I don't hear well. Okay, you want baby blue, dark blue, what? Huh? Which? Dark blue, okay. All right. Now, we have a region over here. We don't have a clue what's going on in it. Okay? Give me another color.
Green this time.
Which one?
Green.
Green this time. Okay, I knew you were going to say that. No. All right. In there, we don't have a clue. We know where it is on the x-axis, but we don't know whether it goes up or down, both ways, different ways. You have several choices there. Oops. I'll take that back. Okay? We have two regions in there. Okay? We have a region here between the vertical asymptote and the 0. Give me another color. Purple. Okay? And we have between the x-intercept and the other vertical asymptote. And then one more color. Yellow. Okay. We have out here. We've got to have 4 test points. Boo hiss. Because we don't know what's happening here. We don't know what's happening between these two, between those two, or anything out here. So, give me a point in one of those intervals. Second? 1. X equal 1. We're going for purple first. Okay? She chose purple. She did that on purpose, didn't she? Okay. So let's go back to purple. All right. Back to purple. Okay. So let's do F of 1. What would that be? Get out of there. 1 over -2. Because 1 minus 1 is 0. And what's 1 over -2? -1/2. So we know that first point is right there. Well, I almost drew my line right on it. There's our first test point. Okay, which one you want to do next? Name a color. Second? Dark blue. Well, no. Okay. Well, which we used before, dark or light? Okay, I meant one of these colors here.
A different color.
No, one of these colors. Light blue, okay.
We didn't use light blue.
See, we did purple because we had purple. Now we're doing light blue.
We did dark blue.
Oh, we did do dark blue. Sorry about that. I thought that was light blue. Okay, dark blue. Well, it's not going right. There we go. So give me a number in dark blue.
3. -3. Sorry.
-3. So what's f of -3? You pick big numbers, don't you? -3 in the numerator over. You can do it one term at a time. -3 squared is 9. Minus a -3 is plus 3 minus 2. So that's going to be something like, since you chose such big numbers, who cares what it is? It's going to be negative, right? Okay, and that negative number is getting close to that horizontal asymptote because it's -3/10, right? Yeah, -3/10. Okay, that was at 3, -3. So -3/10 is somewhere right in there, perhaps. So we know that it's going close to the horizontal asymptote here and going close to the vertical asymptote there. We've got our blue territory covered. Pick another color that's on the screen. Green, okay? And you'll need to pick me a point in green. Hey. Guess what we're down to?
1.
No, once.
A half.
Negative a half. So let's do f of -1/2. Oh, I love these, don't you? Yes. Okay. Numerator, I can do -1/2. Denominator, start one term at a time. -1/2 squared. -1/2 times -1/2. Positive 1/4. Okay? Then minus a -1/2 is plus a 1/2, sorry. And then we got a -2. Okay? Now, frankly, I really don't care too much what the value is. What I'm interested in is what the sign is. This is negative up here. These two are small. Those add to 3/4. This is pretty big, -2. This is going to be negative. That's going to be negative. So we know we're positive there. Somewhere, and if you wanted the actual value, that would be -1. Okay, I'm just going to do 1/2 over, and this will be 3/4, -1 1/4, which is -5/4. Okay, so it'd be 1/2 times 4/5. That would be 2/5. Okay, so 2/5 is somewhere right about there. Okay. All right. We know two things now. We know this one is in the positive territory, so it's going to the vertical asymptote this way. It has to cross through our intercept, and then it goes to the vertical asymptote this way. And it has to pass through our test point there. So we got the green region done. No! I'm sorry. I messed that up terribly. Forget I said that, okay? Any of that. Okay. No, we're right. Yeah. What I was wrong on, I didn't change my colors. Oh, oops. Down here. Okay. Well, that was supposed to be in purple. Yeah. I was right in my drop. I didn't have to change colors. I was just being silly changing colors. But The green region is up here, the purple region is down there. It has to go through the intercept, so that's what it does. You could draw it all in black, that would be better. Got one more region, we still don't know anything about it. So what might we choose as a test point? 3, okay. What color? Oh, that's yellow, isn't it? The one you can't see, okay. So what's f of 3? F of 3 would be 3 over, what did you say? Okay, 9 minus 5 is 4, 3/4. Really don't care too much about the value, though I'll use it. 3/4 is right about there, okay? The main thing about it is its sign. And it's positive, so that means you're going to positive infinity there, positive infinity there. That's it. Oh. Say again?
So that's it.
I can't hear you.
Like that was all.
That was all. All you need is 1 point, because you have to go this way. You have to stay within the red lines. Okay? Within the red lines. Down here, these have to stay within that, but it has to touch here, and these have to stay within that. It touches that. Out here, within the red lines. You know the points down there? Got to stay there. Okay, now I messed it up with colors, but you can do it without colors. Make sense? It's not that bad. Okay. Any questions before we move on? Can you see? Okay. Any questions? Any? If you got them, I'll try to answer them. What's that? Oh, okay. I'm sorry?
Are we going to get one like this one on this?
Oh, let's hope so. Okay. All right.
And every part's worth more points.
What's that?
I said in every part it's worth more points.
It's worth something. Hopefully more than 1 point. Because you get all that right, you get it 7 points. Yeah. Okay. So, all right to erase? Okay. Let's do example 6. Okay? Oh boy. Let me get out of yellow now. Yeah. From 8 to 12. Planning to be anyway. I hope the cold's better anyway. Yuck! This is a cheap flash drive, and any little touching of it is going to pop itself out. Okay. Hopefully it'll stay in. Okay. Example 6. Sketch the graph of f of x. They like f of x, don't they? Is equal to x squared minus 9 x squared minus 2x minus 3. Okay. Now, what you want to do first? Second? I can't hear. Domain. I almost knew she was going to say that. Okay, how do you go about doing the domain? Actually, I like to do one thing first. Y-intercept, how do you do that? Second? Put 0 in for x. So what is f of 0? Pretty easy to do, isn't it? Three, because that becomes a 0, that becomes a 0, that becomes a 0. You got negative 9 over negative 3, which is 3. Okay, so f of 0 is 3. What does that tell you? Y-intercept. So this is the y-intercept is 0, 3, ordered pair, 0, 3. Got it. Now, Rachel wants to find the domain. What's the best way to find the domain? Factor what, specifically? Or generally, huh? Okay. I know y'all said something, but I can't make it up.
You guys said the same thing as the denominator.
The denominator. Okay, let's factor the denominator. And what does that give us? X, what? Minus 3, x plus 1. Y'all check it? Yeah, it works. Second? Yeah, let's factor the numerator as well. Good choice. If you stop there and tried to determine it, well, actually the domain still works there. So let's just say it. I'm going to put it in interval notation this time. So the domain I'll put up here in interval notation is from minus infinity to minus 1, union from minus 1 to 3, and union from 3 to infinity. Okay? The key here, you're excluding minus 1, you're excluding 3, because x can't be 3, x can't be minus 1. So that's why I did it that way. So we'll remember that for later. Now let's factor that numerator. How does it factor, or does it factor? X minus 3 times x plus 3. And now what do you notice? The x minus 3's divide away. Now, that still means x can't be 3. So your domain is still correct. A good idea to choose that first, okay? But what you also, this doesn't become a vertical asymptote because it disappeared. It still can't be in your domain, but it's not a vertical asymptote. Now the only vertical asymptote you have is the minus 1. Okay? So that's what we got from doing that. So here's vertical asymptote is negative 1. I like to say cannot equal negative 1. If you like to say equal negative 1 is your vertical asymptote, that's fine. Perfectly fine. Okay, what else can we do? Horizontal asymptote, let's try that. And what's that going to be? What's going to be 1? Not x. Y is equal to 1. Okay, ratio of leading terms, x squared over x squared is 1. Okay, oh, I didn't say what it was. That was horizontal asymptote. I wrote it backwards, okay. What are we missing? X-intercepts. And what are they? Positive 3 and negative 3. Only trouble is x can't be negative 3, a positive 3. Not 0. Okay, not negative 1. Negative 1 is your vertical asymptote. Your x-intercept. Okay, now this is a tricky one, but it's true. The x-intercept is at is where your y is 0, so x is negative 3, 0. And we want to say 3, 0, except x can't be 3. So what I'm going to do is I'm going to write very palely. Oh, let's just write it in a different color. What color you want it in? Orange. Okay, aren't you glad you chose that? Okay, so that would be, we want to say 3, 0, but we know we can't. So I'm going to put a circle around that. Okay, you don't have to do this on the test, but I'm doing it for a reason. Okay, have we got everything? We got y-intercept, x-intercept, vertical asymptote, horizontal asymptote. Okay, and we got one other point where it can't be. Okay, so let's go back to black and draw our axes. Okay, and tick off a few points. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4. Okay, got it. Let's plot a few things. What you want me to plot first? Say again? What you want me to plot first? Say again? Y-intercept is? Is? And how do I find it? Start at the origin, go up 3. Very good. Okay? Now, so that's your y-intercept, 0, 3. I can see it. So, all right. Next. Say again? Vertical asymptote. And where is that? I'm going to do that in red if you're okay with it. Vertical asymptote is cannot equal -1. So there I plotted that one. Okay. Now I wanted to plot cannot equal +3, but I can't do that. So I'm going to go over here and just put a little red dot on +3. You'll see why in a minute. You can't do a vertical asymptote there. It's not one because it's divided away. Okay? So what's next? Horizontal asymptote is? What is 1? Y is 1. Y is equal to 1. So you do that across here like this. Pretty ugly, but it's there. Get out of there. Okay. Now, what else? We got the second. X-intercept. And what is that? -3. Let me go back to black here. -3, 0, right? I meant to go back to black. Okay. -3, 0 is right there. Agreed? And what did we want to say? We wanted to say, let's put it in orange. We wanted to say that point there, but we can't. Okay? Now, believe it or not, we have everything we need. Okay? And here's why. I'm going back to black here. Here's a point in this quadrant, right? And that's going to the horizontal asymptote in that direction, vertical asymptote in that direction. There we have it. Done. We know we should be over here, but we can't be. So what we do is go up from here and down from there. Okay? Why do we say that? Because we have a hole in the graph right there. It can't be +3, but it acts like it could be +3. So you just have a hole in the graph. I didn't make mine come together very well there.
And that's what they have there.
They have those what? Oh, going upward. Oh, we didn't do the value there, did we?
It's 947.
Yeah, I'm sorry. Okay. Since we went over, we didn't quite finish. So I guess we'll have to have the test on Thursday. Is that okay?
Yeah.
So that gives you another day to get your quiz in. But that means we will be starting Chapter 3 next time. So we'll come in with any questions for Chapter 2. So I'll correct my mistake here on... So forget this. This part was wrong. Okay? We'll go back and reconstitute example 6. Okay. Get your quiz. Oh, yeah, look at your quiz. All right, let me end this.